Good morning, and thank you for joining us today. Could you start by telling me a bit about your background and what led you to pursue a career in Java development?
Good morning. Thank you for having me. I completed my degree in computer science about 3 years ago, and I've been working as a Java developer for the past 2.5 years. I've always had a passion for programming, and from Java stood out to me because of its versatility and the strong community support it has. My first job was with a mid-sized software company where I got to work on several interesting projects, primarily focusing on back-end development. I've gained experience in areas like RESTful web services, multi-threading, and working with databases, which has further fueled my interest in Java development.
So that's great to hear. Let's dive into some technical aspects. Can you explain what OOP object-oriented programming is and how Java supports OOP principles?
Sure, Object-Oriented Programming, or OOP, is a programming paradigm based on the concept of objects, which are instances of classes. The main principles of OOP are encapsulation, inheritance, polymorphism, and abstraction. Java supports OOP by allowing developers to define classes, which are blueprints for objects. Encapsulation is achieved through access modifiers like private, protected, and public, which control access to class members. Inheritance in Java allows a new class to inherit fields and methods from an existing class, promoting code reusability. Polymorphism in Java is mainly implemented through method overloading and method overriding, enabling one interface to be used for a general class of actions. Abstraction is handled in Java through abstract classes and interfaces, which allow the definition of methods that can be implemented by subclasses. For example, in a project, I designed a system for managing employee records where we had a base class employee and derived classes like manager and developer. This design helped to reuse code effectively and manage different types of employees with minimal changes in the code base.
That's a solid explanation. How do you handle exception handling in Java? Can you give an example from your experience where exception handling was crucial?
In Java, exception handling is managed through the use of try, catch, finally, and throws keywords. The idea is to handle runtime errors so the program doesn't crash unexpectedly. The try block contains code that might throw an exception, while the catch block handles the exception, preventing it from propagating further. The finally block, if used, is executed regardless of whether an exception occurred or not, typically for cleaning up resources like closing file streams or database connections. In one of my projects, we were developing an application that processed large sets of financial data. During this process, we had to deal with potential I/O exceptions while reading data from files and SQL exceptions during database interactions. I implemented a try-catch block to handle these exceptions and ensure that proper logs were generated for any errors encountered. This not only helped in debugging, but also ensured that the application could continue processing other data even if one file had issues.
Handling exceptions is crucial, especially in large-scale applications. How comfortable are you with multi-threading in Java? Can you discuss a situation where you used multi-threading?
I'm quite comfortable with multi-threading in Java. Multi-threading allows multiple threads to run concurrently, making the best use of CPU resources, especially in a multi-core environment. Java provides robust support for multi-threading through the thread class and the runnable interface. In one project, I worked on an e-commerce platform where we had to generate invoices for orders. This process involved multiple tasks, such as calculating totals, applying discounts, and updating inventory, all of which could be done independently. I used multi-threading to perform these tasks concurrently, significantly reducing the time taken to process each order. Additionally, I implemented thread synchronization to manage shared resources like inventory records to prevent race conditions.
That's a good use of multi-threading. Speaking of synchronization, can you explain how thread synchronization works in Java and why it's important?
Certainly. Thread synchronization in Java is a mechanism that ensures that multiple threads can access shared resources safely without causing data inconsistency or corruption. Java provides several ways to achieve synchronization, the most common being the synchronized keyword. This can be used to lock an object or a block of code so that only one thread can execute it at a time. For example, in the e-commerce project I mentioned earlier, when multiple threads were updating the inventory, I used synchronized blocks to lock the inventory object. This ensured that only one thread could modify the inventory at a time, preventing issues like overselling of products. Synchronization is crucial in scenarios where multiple threads interact with shared resources, as it helps maintain data integrity and prevents hard-to-debug issues like race conditions.
Exactly, synchronization is key to maintaining consistency. Moving on, can you explain the difference between wait and sleep methods in Java?
Yes, both wait and sleep are methods used in Java to pause the execution of threads, but they serve different purposes and behave differently. The sleep method is a static method of the thread class. It causes the current thread to pause execution for a specified period, allowing other threads to execute. However, the sleep method does not release the lock or monitor if the thread holds one, meaning it will continue holding any synchronization locks. On the other hand, the wait method is a non-static method of the object class. It's used for inter-thread communication, particularly in situations involving thread synchronization. When a thread calls wait, it releases the lock it holds on the object and enters a waiting state until another thread calls notify or notify all on the same object. This is useful in scenarios where threads need to wait for some condition to be met before proceeding. For instance, in a producer-consumer scenario, a producer thread might wait until there's space in the buffer to produce more items, while a consumer thread might wait until there are items in the buffer to consume. The notify method would then be used to wake up the appropriate thread when the condition is met.
It's a great explanation. How do you approach memory management in Java, particularly with garbage collection?
Memory management in Java is largely handled by the JVM through garbage collection, which automatically frees up memory that is no longer in use. This is one of the advantages of Java, as it reduces the risk of memory leaks and other issues associated with manual memory management. Garbage collection works by identifying objects that are no longer reachable from the root references, like active threads, static fields, or local variables on the stack. These objects are then eligible for garbage collection. Java uses several algorithms for garbage collection, including mark and sweep, generational garbage collection, and others. However, as a developer, I still need to be mindful of memory management practices. For example, avoiding memory leaks by properly closing resources like database connections or file streams, and being careful with object references that are no longer needed. I also try to use weak references where appropriate, especially when working with caches, to allow the garbage collector to reclaim memory if needed. In a project, I once encountered an out-of-memory error due to improper handling of a cache. We were using a hash map to store objects that were not being cleaned up, leading to memory bloat. I refactored the code to use a weak hash map, which automatically removes entries when the key is no longer in use, helping to avoid the memory issue.
Managing memory effectively is indeed crucial, especially in long-running applications. How familiar are you with Java 8 features, particularly lambdas and streams?
I'm quite familiar with Java 8 features, including lambdas and streams, and I've used them extensively in my projects. Lambda expressions in Java 8 provide a clear and concise way to represent a method interface using an expression. They are particularly useful when working with collections or performing operations that involve a lot of boilerplate code, such as filtering or mapping. Streams, on the other hand, provide a powerful abstraction for processing sequences of elements, such as collections. They allow developers to perform operations like filtering, mapping, and reducing in a declarative manner, often in a single line of code. For example, in one project, I had to process a list of orders to filter out the completed ones and calculate the total revenue. Using streams and lambdas, I was able to achieve this in a clean and concise way. Double total revenue equals orders stream. Filter order.status equals completed. Map to double order get total amount. This code is much more readable and easier to maintain compared to traditional loops and conditionals.
That's a very practical use of streams and lambdas. How would you handle a situation where you need to optimize performance in a Java application?
Performance optimization in Java can involve several strategies, depending on the nature of the application and where the bottlenecks are occurring. The first step is always to profile the application to identify the slowest parts. Tools like Visual VM or JProfiler are useful for this. Once the bottlenecks are identified, I would consider various strategies. For instance, if the issue is with database access, I might look into optimizing queries, adding indexes, or using caching to reduce the number of database hits. If the issue is related to CPU-bound tasks, I might consider optimizing algorithms, using more efficient data structures, or implementing parallel processing with multi-threading or parallel streams. In one project, we noticed that the application was slowing down during peak hours. Upon profiling, we discovered that the main bottleneck was in the method responsible for calculating discounts, which was being called frequently and involved complex logic. I optimized this method by simplifying the logic and caching the results of expensive calculations, reducing the load on the CPU, and improving response times.
Profiling and targeted optimization are indeed key to performance improvements. How do you ensure code quality in your projects?
Ensuring code quality is a priority for me, and I approach it from several angles. First, I adhere to coding standards and best practices, such as following naming conventions, writing modular and reusable code, and documenting where necessary. Second, I make use of unit testing to validate individual components of the application. I typically use Junit for writing test cases and Mockito for mocking dependencies. Writing tests not only helps in catching bugs early, but also ensures that future changes do not break existing functionality. Third, I perform code reviews with my team. This is an excellent way to catch potential issues and learn from each other. We use tools like GitHub for code reviews, where team members can comment on each other's code before it gets merged. Lastly, I use static code analysis tools like SonarQube or CheckStyle to identify potential issues, such as code smells, duplications, or security vulnerabilities, early in the development process. For instance, in my last project, we had a strict code review process where every piece of code had to be reviewed by at least one other developer before it could be merged. This helped in maintaining a high standard of code quality and also facilitated knowledge sharing among the team.
Code reviews and testing are indeed critical for maintaining quality. Could you tell me about a challenging bug you encountered and how you resolved it?
Certainly. In one project, we encountered a particularly challenging bug related to data inconsistency in our application. The issue was that occasionally, the application would show outdated data even though the underlying database had been updated. This was particularly frustrating because it didn't happen consistently, making it hard to reproduce. After a thorough investigation, I found that the problem was related to caching. We were using an in-memory cache to store data for faster access, but the cache was not being invalidated correctly when the database was updated. As a result, the application was sometimes showing stale data from the cache instead of the updated data from the database. To resolve this, I implemented a proper cache invalidation strategy. I modified the application to clear the relevant cache entries whenever the database was updated. Additionally, I added a time-based expiration for cache entries to ensure that even if an invalidation was missed, the data wouldn't stay stale for long. This fix resolved the issue, and we didn't encounter any more instances of data inconsistency.
Cache invalidation can indeed be tricky. It sounds like you handled it well. How do you keep yourself updated with the latest developments in Java and software development in general?
I believe continuous learning is crucial in our field, given how quickly technology evolves. To stay updated with the latest developments in Java and software development, I follow several strategies. First, I regularly read blogs and articles from well-known Java and software development websites like dzone, Baildung, and Stack Overflow. These sources often provide insights into new features, best practices, and solutions to common problems. Second, I attend webinars, conferences, and meetups whenever possible. These events are great for learning from experts, discovering new tools and frameworks, and networking with other professionals in the field. Third, I make a habit of experimenting with new features or tools in side projects. For example, when Java 8 was released, I built a small project to explore and understand lambdas, streams, and the new datetime API. Finally, I participate in online courses and tutorials on platforms like Coursera, Udemy, and Pluralsight. These platforms offer a wide range of courses on everything from core Java concepts to advanced topics like microservices or cloud computing.
It's great to see that you're proactive about staying current. Can you discuss your experience with version control systems, particularly Git?
I have extensive experience with Git as a version control system, and I've been using it since the beginning of my career. Git is a powerful tool that helps in tracking changes to the codebase, collaborating with other developers, and managing different versions of a project. I'm comfortable with all the basic Git operations like cloning repositories, creating branches, committing changes, merging branches, and resolving conflicts. I also use more advanced features like rebasing, cherry-picking commits, and using tags for release management. In my last job, we followed a branching strategy based on Git flow. We had separate branches for features, releases, and hotfixes, which helped us manage the development process effectively. I also made use of GitHub's pull request feature for code reviews and collaborated with other team members by commenting on code, suggesting changes, and discussing potential improvements. For example, during a critical project release, I was responsible for managing the release branch. I had to ensure that all features were properly merged, conflicts were resolved, and the branch was stable before the release. This required careful coordination with other developers and attention to detail to avoid any last-minute issues.
Your experience with Git and version control systems is solid. How do you approach working in a team environment, especially when it comes to collaborating on large projects?
Collaboration is key in any team environment, especially on large projects where multiple developers are working on different parts of the code base. I believe in clear communication, mutual respect, and a collaborative mindset. In a team setting, I make sure to communicate regularly with my colleagues. This includes daily stand-ups, where we discuss what we're working on, any blockers we're facing, and how we can help each other. I also ensure that I'm available to assist others when needed, whether it's through pair programming, code reviews, or simply discussing a problem. Documentation is another important aspect. I make sure to document my code and the decisions behind it so that other team members can understand and work with it easily. This is particularly important in large projects where different parts of the codebase are interdependent. In one project, we were working on a complex microservices architecture. Effective collaboration was crucial because each service had to interact seamlessly with others. We used tools like Slack for communication, Jira for task management, and Confluence for documentation. By keeping everyone in the loop and being proactive in resolving any issues that arose, we were able to deliver the project on time and with high quality.
Finally, what are your long-term goals as a Java developer, and how do you see yourself growing in this field?
My long-term goal as a Java developer is to continue growing my technical skills while also expanding my knowledge in related areas like architecture and design patterns. I'm particularly interested in areas like microservices, cloud computing, and DevOps, as these are becoming increasingly important in modern software development. In the short term, I'm focused on deepening my expertise in Java, mastering the latest features, and learning more about performance optimization and scalability. I also want to take on more responsibilities, such as leading a team or mentoring junior developers, as I believe this will help me grow both technically and professionally. In the long term, I aspire to move into a role that involves more architectural decision-making, where I can design and oversee the development of complex systems. I'm also interested in contributing to the open-source community, sharing my knowledge and learning from others. Overall, I see myself growing as a well-rounded software engineer who can contribute at both the code level and the architectural level, helping to build scalable, high-performance applications that meet the needs of users.
That's a great vision for your career. Thank you for sharing your insights and experiences with us today. It's been a pleasure discussing your journey and your approach to software development. We'll be in touch soon with the next steps.
Thank you for the opportunity to interview. I really enjoyed our conversation and look forward to hearing from you. Have a great day.